The Great Pyramid stands as a silent challenge to history. We are taught the ancient Egyptians built their wonders alone, with copper tools and endless labor. But what if that story is incomplete? For decades, a compelling alternative has whispered from the edges of archaeology. It suggests a profound secret, that the spark of this magnificent civilization may have come from somewhere else or someone else. By the end of this, you will have a complete toolkit to dissect this epic mystery for yourself. We will examine the jaw-dropping precision that defies easy explanation and meet the phantom candidates from a drowned Atlantis to watchers in the stars. We will also hear the powerful case for human genius alone. So where does the truth lie between an impossible achievement and an incredible helper? The official story is one of breathtaking human determination. According to mainstream Egyptology, the civilization along the Nile developed entirely on its own timeline. Around 4,600 years ago, the Old Kingdom emerged, a period of unprecedented central power and ambition. The pharaohs, seen as living gods, commanded the resources of an entire nation. To build their eternal homes, they relied on tools we would consider primitive by today's standards: copper chisels, stone pounders, and ropes made from papyrus. The transportation of million-ton blocks is attributed to ingenious engineering, using wooden sleds dragged over wet sand to reduce friction, and massive earthen ramps spiraling up the construction site. The workforce, far from being slaves, is now understood to have been a rotating core of skilled laborers and farmers who worked during the Nile's annual flood, when their fields were underwater. They were housed, fed, and honored for their service. This narrative paints a picture of a society so brilliantly organized, so unified in purpose, that it could marshal tens of thousands of people for decades to achieve the impossible. The results speak for themselves: not just the Great Pyramid at Giza, but the entire sacred landscape, the towering obelisks carved from single stones, the vast columned halls of Karnak, all testaments to a culture that mastered stone, astronomy, and administration. It is a story of self-made genius, a triumph of the human spirit that we are taught to admire. And yet, it is precisely the magnitude of this solo achievement that fuels the mystery. When you stand before the Great Pyramid, its blocks fitting together with a precision of a fraction of an inch, its sides aligned almost perfectly to the cardinal points, a quiet question forms. Could willpower and copper tools alone really account for this? The standard narrative is powerful, but it leaves a gap between what we know they had and what they seemingly accomplished. That gap is where speculation takes root. That gap between tools and achievement is nowhere more visible than in the stone itself. The Great Pyramid of Giza is not merely big, it is unnervingly precise, a machine of stone built with a degree of accuracy that feels out of place in its time. Let us start with its orientation. The pyramid's base is a near-perfect square, and its four sides are aligned to the cardinal points of the compass with an error of just 3/60ths of a single degree. To put that in perspective, that is more accurate than the alignment of the Royal Observatory in Greenwich, built millennia later. This is not roughly facing north, this is targeting true north with a sniper's precision, achieved without magnetic compasses, which the Egyptians did not have. They did it by tracking the stars, likely using a method called the simultaneous transit, observing the circular path of a single star to find the celestial pole. The execution of this idea, translating it from the night sky to a 500 million kilogram stone footprint on the ground, is a staggering feat of applied astronomy. Then we have the numbers encoded in its shape. The ratio of the pyramid's perimeter to its height is remarkably close to 2 times pi. This is the mathematical constant that defines the relationship between a circle's circumference and its diameter. There is also a recurring appearance of the golden ratio, a special number often found in nature and art, embedded in the pyramid's internal geometry. Now, mainstream scholars argue the Egyptians may not have known pi as a formal constant, and that these ratios could be a byproduct of their chosen slope and measurement system. But the coincidence is striking. It is as if the blueprint for the pyramid was drawn using a sophisticated mathematical language, one that we recognize but they supposedly did not speak fluently. But the most visceral evidence is in the touch and fit of the stones. We are not talking about the rough core blocks hidden inside. We are talking about the original casing stones, the smooth, white Chura limestone that once sheathed the entire structure, making it gleam like a jewel in the desert sun. Few of these remain, but the ones that do, particularly at the base, tell a story. The joints between these massive casing blocks are not just tight, they are virtually invisible. The gaps are often less than 1/50th of an inch, thinner than a credit card. The surfaces are so flat and true that they did not need mortar. The blocks simply locked together by their own precision. This is a level of stoneworking that rivals modern machining. To achieve this with copper saws, stone abrasives, and manual labor challenges our understanding of their capabilities. It suggests a knowledge of materials, of geometry, of surveying that seems to leapfrog the expected technological progression. It feels less like a gradual improvement and more like a fully formed skill, appearing almost at the dawn of the civilization's great works. This precision is the first loud anomaly, a silent scream in stone that something extraordinary happened here, something that the standard toolbox of copper and rope struggles to fully explain. This impossible precision points to a deeper riddle, one carved not from geometric blocks but from the living bedrock of the Giza Plateau itself. Gazing across the sands at the Great Pyramid, our eyes are inevitably drawn to its silent companion, the Great Sphinx. This colossal statue of a lion with a human head, traditionally attributed to Pharaoh Khafre around 2500 BC, is presented as the world's oldest and largest monumental sculpture. But what if the Sphinx is guarding a secret far older than the pharaoh it is said to represent? The controversy begins not with artifacts or inscriptions, but with the very stone it sits within. Look at the walls of the Sphinx enclosure, the deep trench cut from the limestone bedrock that surrounds the statue. Orthodox archaeology explains the heavy weathering on these walls as the result of wind and sand over millennia. Yet in the 1990s, a geologist named Robert Schoch looked at those same walls and saw something entirely different. He saw the distinctive patterns of water erosion. Not the sharp, sand-blasted pitting of a desert wind, but the deep, rolling, undulating vertical channels and recesses that are classically formed by prolonged, heavy rainfall. This was a problem because the climate of Giza has been hyper-arid, a desert as dry as it is today, for at least the last 5,000 years. To create the type of erosion Schoch identified would require a climate that was significantly wetter, a time when the region experienced persistent torrential rains. Based on the geological evidence, that last rainy period in Egypt ended around 7,000 years ago, possibly even earlier. If the water erosion on the Sphinx enclosure is primary, meaning it happened after the trench was carved, then the core structure of the Sphinx must date back to that wet epoch, potentially placing its origins at 5000 BC or even before. That is a staggering thought. It would mean the Sphinx, or at least its core body, predates the dynastic Egyptians by thousands of years. It would mean that when Pharaoh Khafre came to the plateau, he might not have been building a new monument, but renovating and recarving a primordial guardian that was already ancient, its original features weathered away by rains that fell when the Sahara was a green savanna. Mainstream Egyptology strongly disputes this interpretation. Scholars point out that the weathering could be from subsurface groundwater or from the effects of wind-driven rain in occasional, rare storms. They firmly anchor the Sphinx to Khafre, citing the style of the face, the layout of the nearby temples, and the lack of any archaeological evidence for such an advanced pre-pharaonic culture at Giza. The debate is fierce, a classic clash between hard geology and traditional archaeology, but the water erosion theory plants a powerful seed of doubt. It suggests the timeline we have accepted might be a palimpsest, a later story written over a much older one. If the Sphinx is a relic from a forgotten, rain-soaked age, then who carved it? What civilization, lost to the sands of a deeper time, could have been the first to shape the Giza Plateau? This question forces us to look beyond the Nile Valley to the realm of myth and the whispers of a cataclysm. The geological whispers from the Sphinx lead us south to a place where the stones tell an even stranger architectural story. Abydos, one of ancient Egypt's most sacred cities, is home to the magnificent temple of Seti I, a masterpiece of New Kingdom artistry with its crisp, detailed reliefs and elegant columns. But hidden directly behind it, sunk into a deep pit as if trying to return to the earth, lies the Osirion. This structure is an absolute anomaly. It is built from colossal blocks of red granite, each one weighing tens, even hundreds of tons. The style is brutally simple, stark, and massive, a technique often called Cyclopean masonry. There are no intricate carvings here, no refined artwork. Just these immense, perfectly squared monoliths fitted together with the same hairline precision we saw at Giza. The entire design is unique. It is essentially a rectangular island surrounded by a water-filled channel, an architectural echo of the mythical mound of creation emerging from the primordial waters. And that is the core of the mystery. The Osirion looks nothing like the temple it sits behind. Seti's temple is classic, refined Egyptian architecture from around 1300 BC. See, the Osirion looks primordial, archaic, and vastly older. Its foundation sits at a much lower level than Seti's temple, suggesting it was already an ancient, buried ruin when the New Kingdom pharaohs decided to build their own sacred complex above and around it. The official explanation is that it is a cenotaph, a symbolic tomb for the god Osiris, built by Seti I, but in a deliberately archaic style to evoke great antiquity. Yet for many, this explanation feels insufficient. The difference is not just stylistic, it is fundamental. It is the difference between building with bricks and building with mountains. The logistical challenge of quarrying, moving, and positioning these granite behemoths is immense even for the peak of Egyptian civilization, let alone for a project meant as a symbolic throwback. The Osirion feels like a relic, a piece of a much older puzzle reused and reinterpreted by a later culture. This sense of an older, lost layer at Abydos gets a bizarre, pop culture twist just a short walk away. Inside the Temple of Seti, on a lintel above a doorway, is a set of curious carvings that have ignited the imaginations of millions. They are often called the helicopter hieroglyphs. To the modern eye, one cluster of symbols looks uncannily like a helicopter with what appears to be a rotor blade and tail. Nearby, other shapes resemble a submarine, a jet plane, and a futuristic craft. The internet is full of theories that these are proof of advanced technology or time travel. The reality is far more mundane, but no less fascinating as a lesson in how history gets rewritten. Egyptologists have clearly demonstrated that these are not singular, mysterious images. They are the result of palimpsest of recarving. A pharaoh would often have the name and titles of a predecessor chiseled out and his own carved in its place. Here, the original hieroglyphs, the name of Seti I, were later plastered over and recarved with the name of his son, Ramesses II. Over centuries, the plaster fell away, leaving both sets of carvings partially visible, superimposed on one another. The overlapping shapes, a product of chance and erosion, created these bizarre, modern-looking silhouettes. They are a historical accident, not a blueprint. Yet their popularity speaks to a deep human desire in this mystery. When we see the Osirion's impossible stones and then glimpse a helicopter on a temple wall, the mind wants to connect them. It wants a single, spectacular answer, a lost civilization with technology we would recognize. but the truth is usually layered, more complex, and often written in stone more than once. The stones of Abydos whisper of lost time, but the walls of Dendera seem to scream with a secret we can almost understand. Deep within the Temple of Hathor, a relief carved in the late Ptolemaic or early Roman period around 2,000 years ago presents an image so startlingly modern it has become a cornerstone of ancient astronaut theories. The scene is often called the Dendera light. It shows two large bulb-shaped objects, each held aloft by a standing figure. Inside each bulb, a snake stretches the full length, its head pointed toward one end. A cable seems to run from the base of the bulb, held by a priest, and connects to a small box on which a baboon sits. Most intriguingly, the bulb itself is supported by a jed pillar, a symbol of stability often linked to the backbone of the god Osiris. To a modern eye, the interpretation is irresistible. It looks like a giant, ancient light bulb. The snake is the filament, the jed pillar is the insulator, the cable is the power cord, and the box is the battery or generator. The baboon, associated with the god Thoth of wisdom, could be the technician. It is a perfect, self-contained image of electrical technology, seemingly preserved in stone for millennia. This interpretation taps into a powerful desire to see our own world reflected in the past. Proponents argue that the relief shows a practice too dangerous to perform in the open, perhaps the creation of an electric arc or a Crookes tube, with the priests using primitive batteries like the Baghdad battery to generate a mysterious glow within the temple's inner chambers. They point to the absence of soot in many deep Egyptian tombs and temples, asking how they could have been illuminated without advanced light sources. The Dendera relief, in this view, is the missing manual, a technical diagram hiding in plain sight. But Egyptology offers a profoundly different, symbolic reading that dismantles the technological interpretation piece by piece. According to scholars, this is not a light bulb manual but a rich mythological scene. The bulb is not a glass enclosure but a depiction of a lotus flower, a powerful symbol of creation emerging from the primordial waters. The snake inside is not a filament but a representation of the sun god, often shown as a serpent traveling through the night before being reborn at dawn. The entire scene is a depiction of the daily cycle of the sun, its journey through the underworld and its triumphant rebirth. The jed pillar, a symbol of stability and resurrection, supports this cosmic process. The cable is not a wire but a stylized lotus stem, and the box is a symbolic shrine. The baboon, sacred to Thoth, is there because baboons were believed to greet the rising sun with chattering cries, making them perfect attendants for a scene about solar rebirth. This clash of interpretations is a perfect microcosm of the entire mystery. On one side, a literal, technological reading that sees a direct parallel to modern invention. On the other, a contextual, cultural reading that sees a sophisticated language of symbol and myth. The Egyptological view asks us to step into the ancient Egyptian mind, to understand that their art was not meant to document gadgets but to encode cosmic truths. The absence of soot in tombs is explained by the clever use of polished metal mirrors to reflect sunlight deep into passages, or by the fact that workers simply used oil lamps and ventilated the spaces. The Dendera light then becomes a test. Do we see what we want to see, a reflection of our own technological world? Or do we see what the builders intended, a poetic and spiritual expression of their universe? The answer you lean toward reveals much about how you bridge that tantalizing gap between their ancient genius and our modern assumptions. The clash over the Dendera light reveals a fundamental divide in how we interpret the past. When confronted with a gap between known tools and apparent achievement, the human mind instinctively searches for a source, a teacher, a lost chapter. And no lost chapter has captured our collective imagination more powerfully than the first and most famous candidate for that ancient helper, Atlantis. This is not a modern invention, but a story from the very dawn of Western philosophy, told by the Greek thinker Plato around 360 B.C. In his dialogues Timaeus and Critias, Plato describes through the voice of an Egyptian priest a magnificent island empire that existed 9,000 years before his own time. This was not a primitive society. Atlantis, according to Plato, was a marvel of engineering and order. It had concentric rings of land and water, bridges, canals, and a grand capital city adorned with precious metals. Its people possessed advanced knowledge of architecture, agriculture, and navigation. They were a great naval power, benevolent at first but later corrupted by pride and greed. Their fate was a cataclysm of mythic proportions. In a single terrible day and night of earthquakes and floods, the entire island sank beneath the ocean, vanishing forever. For theorists, this story is not mere allegory. They hear in it the echo of a real historical event, a memory of a sophisticated culture that was literally wiped off the map. The timeline is the first hook. Plato's Atlantis falls 9,000 years before Solon, which would place its destruction around 9,600 B.C. This predates the rise of dynastic Egypt by several millennia. The theory proposes that not all Atlanteans perished. Survivors, scattered by the disaster, would have been refugees carrying the remnants of their advanced knowledge. Where would such refugees go? To the nearest stable, fertile land with a great river, a place where they could rebuild. The Nile Valley would have been a perfect sanctuary. These survivors then become the mysterious gods or first ones of Egyptian legend, the bringers of agriculture, astronomy, monumental architecture, and law. They provide the missing link, the sudden spark of high civilization along the Nile. The search for a physical Atlantis has fueled expeditions and speculation for centuries. Proposed locations are as varied as the theories themselves. Some place it in the Mediterranean, perhaps the volcanic island of Santorini, whose massive eruption around 1600 B.C. devastated the Minoan civilization. Others look to the Atlantic Ocean, pointing to underwater formations like the Bimini Road in the Bahamas or the Azores Plateau. A few even suggest Antarctica, theorizing a shift in the Earth's crust. Mainstream archaeology dismisses all of these, noting that Plato's account is a philosophical parable about the ideal state and its downfall, not a historical record. No geological evidence supports a continent sinking in the Atlantic within human history, yet the myth persists with undying strength. Why? Because Atlantis serves a profound psychological purpose. It is the perfect vessel for our awe. When we stand before the Great Pyramid, a small, rational part of us whispers that the standard story of copper tools and ramps might be incomplete. Atlantis offers a grand, romantic, and satisfying answer. It externalizes genius. It says we did not slowly, painfully climb this mountain of achievement alone. We were given a boost by a greater, older, wiser people who are now gone. Their tragic loss absolves us of the need to find their ruins among ours, and their advanced nature explains the precision that haunts us. Atlantis is the ultimate deus ex machina for history's greatest puzzles. But if Atlantis is a phantom from the deep, perhaps our gaze should turn upward to an even more radical source of ancient wisdom. Atlantis lifts our gaze to a drowned world, but the truth may be buried much closer to home, right under the desert sands of Egypt itself. If the Sphinx's weathered flanks hint at a timeline out of place, could there be physical proof of a forgotten people who walked the Nile Valley long before the first pharaoh? This leads us to a second, more grounded candidate, an unknown pre-dynastic culture, a civilization zero. The traditional narrative holds that Egypt's story began with the unification of Upper and Lower Egypt around 3100 B.C. under King Narmer. But what came before that moment of political birth? The pre-dynastic period is often painted as a time of simple, Neolithic farming villages, gradually developing toward complexity. However, scattered across the landscape are enigmatic clues that suggest this gradual rise might have had a sudden, inexplicable spark. Far to the south, in the brutal emptiness of the Sahara, lies a site that shatters our expectations of what early people were capable of. Nabta Playa, today it is a hyper-arid basin, but around 7,000 years ago it was a savanna with a seasonal lake. The cattle-herding people who lived there did something extraordinary. They arranged a series of large stone slabs into a complex astronomical arrangement. This is not a random pile of rocks. Analysis shows the stones align with the rising points of key stars like Sirius and the belt of Orion and mark the summer solstice. It is one of the oldest known astronomical observatories in the world, predating Stonehenge by over 1,000 years. These nomadic herders were tracking the heavens with a sophistication that seems to leap ahead of their supposed lifestyle. Why would cattle herders need such a precise calendar to predict the coming of the seasonal rains, vital for survival? But the ambition of the project speaks to a deep, organized understanding of cosmic cycles, a knowledge that feels like a prerequisite for the later pharaonic obsession with star-aligned monuments. Then we have the artifacts themselves. From the predynastic graves of places like Nakoda and Hierakonpolis, we find objects of stunning artistry and mystery. Exquisitely carved palettes of siltstone, like the Nama palette which celebrates the unification, show an artistic convention and symbolic language already fully formed. But even earlier, we find the so-called disc maceheads and strange, pear-shaped stone objects whose purpose is unknown. Most intriguing are the advanced flint tools. The craftsmanship is so fine, with blades' pressure flaked to a razor's edge and symmetry that is almost machine-like, that they seem to belong to a later age. This was not crude tool-making, it was an art form. Could these artifacts be the fingerprints of a culture that had already mastered materials, symbolism, and astronomy? A culture whose peak was reached and then lost, perhaps to climate change as the Sahara dried. Their legacy, in this theory, was not carried by refugees from a sunken continent, but was inherited by the people who remained along the Nile. The first pharaohs, then, were not the inventors of this high civilization, but its brilliant successors. They found the scattered knowledge, the sacred sites, perhaps even the half-buried monuments, and wove them into a new, powerful state religion and identity. They became the curators of a forgotten genius, claiming it as their own divine right. This idea transforms the narrative. The Great Pyramid is no longer a stunning first attempt, but a staggering culmination, the ultimate expression of a science and a spirituality that had been brewing in the region for millennia. The pre-dynastic culture becomes the ghost in the machine, the silent partner whose name was erased by time, but whose handiwork set the stage for everything that followed. Yet, if we are searching for a teacher so advanced they seemed like gods, why look to the earth or the sea at all? Perhaps the most profound answer has always been written in the night sky, waiting for us to look up. The night sky over ancient Egypt was not just a canopy of lights, it was a living map of gods and cosmic journeys. For proponents of the ancient astronaut theory, this was not mythology, it was memory. This third candidate for Egypt's mysterious helper does not come from a lost continent or a forgotten human culture, but from the stars themselves. Popularized by television shows and books, this idea suggests that the beings the Egyptians worshipped as gods were not supernatural spirits, but highly advanced extraterrestrial visitors. In this view, the stories are not allegories, they are eyewitness accounts, blurred by time and translated into a pre-technological language. The sun god Ra, traversing the sky in his solar bark, becomes a description of a luminous craft. Thoth, the ibis-headed god who gave humanity writing, medicine, and law, is reinterpreted as an alien scientist, a bearer of knowledge. The strange headdresses and animalistic features of the gods are seen not as symbolic art, but as clumsy attempts to depict the helmets and biomechanical suits of otherworldly visitors. The precision of the pyramids, then, is not a human triumph, but a gift, or perhaps a task assigned by these star-born overseers who needed these structures for purposes we can only guess at, from energy generation to celestial navigation beacons. This theory often points to curious artifacts as potential evidence. One of the most cited is the Tully Papyrus. Unlike most Egyptian texts, this is not a well-preserved scroll in a museum. It is a modern transcription of a transcription, a copy of a document said to have been seen in Cairo in the 1930s. The text, allegedly from the reign of Thutmose III, describes a miraculous event. It tells of circles of fire appearing in the sky brighter than the sun, which eventually departed to the south. Proponents highlight this as a clear historical record of a UFO sighting over pharaonic Egypt. Mainstream scholars, however, dismiss the Tully Papyrus as at best a mistranslation of a known astronomical text, or at worst, a modern hoax. They note the original papyrus has never been produced for study, and the language in the transcription does not match typical Egyptian phrasing. The ancient astronaut theory thrives on this pattern, recontextualizing the sacred and the symbolic into the literal and technological. It asks a compelling question: what if every myth has a kernel of truth, and that truth is a visitation? It offers a single, spectacular solution to all our mysteries, from the Sphinx's age to the pyramid's math. But in doing so, it requires us to believe that an entire civilization built a religion, an art style, and a national identity around a profound misunderstanding of their own benefactors. It turns the intricate poetry of Egyptian belief into a simple case of cargo cult, where the gods were just pilots who forgot to close the hangar door. This leaves us with the most tangible piece of the puzzle: the tools themselves. The archaeological record of ancient Egypt is not silent on this matter. We have found their workshops, their quarries, and their toolkits. The inventory is, on the surface, disarmingly simple: copper chisels and saws, which are relatively soft metal; stone dolerite pounders used for bashing away at granite; wooden mallets and wedges; ropes of papyrus and palm fiber; sand, water, and wood for sleds. This is the official toolbox, the one we point to and say, with this, they built a civilization. Yet when we hold these simple implements in one hand and look at their creations with the other, a cognitive dissonance sets in. The gap feels less like a step and more like a canyon. Take the granite beams in the King's Chamber of the Great Pyramid. These are not small stones. Each one is a slab of red granite weighing around 70 tons. They were quarried in Aswan, over 500 miles up the Nile. The engineering to move a single one of these behemoths is staggering. They would have been loaded onto a massive wooden barge during the Nile's flood season, floated down river, then offloaded, dragged across the desert, and finally lifted over 200 feet into the heart of the pyramid structure. All with ropes, wooden rollers, and manpower. The precision with which they were placed is another layer of mystery. They fit together with the same hairline joints we see elsewhere. How do you achieve that level of finish on a 70-ton block with a copper saw? Copper is softer than granite. Egyptologists explain that they used an abrasive like quartz sand and sawed by essentially grinding the stone away, a process that is incredibly slow but possible. But the scale and perfection required push the limits of that explanation. Then there are the artifacts that defy even that grinding method. In museums, you can find ancient Egyptian vases carved from incredibly hard stone like andesite or diorite. These vases have thin, perfectly symmetrical walls, often with a slight bulge or complex curve. Their surfaces are flawlessly smooth with a lustrous, almost glass-like polish. Some have hieroglyphs or delicate fluting carved into them with crisp, sharp edges. To modern artisans, these pieces scream one thing: a lathe. The symmetry is too perfect, the curves too consistent, the polish too even to be the product of hand chipping and sanding alone. The suggestion is that the ancient Egyptians possessed some form of rotary machinery, perhaps a bow-driven lathe or a steam-powered wheel, to spin the stone while a cutting tool was applied. While no such machine has been found, the artifacts themselves stand as silent witnesses to a technique we have not fully reconstructed. Perhaps the most breathtaking feat of all is the quarrying and raising of obelisks. These were not built from blocks. Each obelisk was a single, slender needle of red granite, sometimes weighing over 400 tons. The quarrymen would first carve the shape of the obelisk directly into the living bedrock, undercutting it and leaving it attached by a thin spine of stone. Then, using a system of levers and perhaps by heating that spine to fracture it, they would detach this mountain of stone. The process of transporting it, often on a specially built giant barge, and then erecting it vertically in a temple courtyard without it snapping under its own weight, is an engineering puzzle we still debate. The risk, the coordination, the sheer confidence required is staggering, so we return to the core question posed by these objects. Is the journey from copper chisel to 400-ton obelisk a natural, linear evolution of human ingenuity? Can we chart a clear, step-by-step progression where each generation slightly improved on the last until they reached this pinnacle? Or does the sheer audacity and perfection of these early achievements suggest something else? Could it indicate a moment of knowledge transfer where a core set of advanced principles about leverage, about material science, about precise measurement, were introduced fully formed and then applied with increasing ambition over centuries? The tools we have found may not be the whole story. They might be the everyday implements that maintained a technology whose origin remains just out of sight. The silent stones of Giza hold a conversation not just with the Earth but with the cosmos itself. This is where the mystery shifts from engineering to astronomy, revealing a celestial blueprint woven into the very fabric of their monuments. The most famous of these stellar maps is found in the arrangement of the three Great Pyramids. While not a perfect match, their layout on the desert floor bears a striking resemblance to the three stars of Orion's belt. This is no casual observation. In Egyptian mythology, Orion was associated with Osiris, the god of death, resurrection, and the afterlife. The Nile River, flowing beside the pyramids, was seen as a terrestrial mirror of the Milky Way. The entire Giza Plateau, then, becomes a sacred landscape, a perfect map of the heavens built on Earth to ensure the pharaoh's soul could navigate its way to the eternal stars. The correlation is compelling, suggesting the architects were not merely building tombs, but constructing a permanent gateway aligned with a specific celestial region. This cosmic intent becomes even more personal and precise inside the Great Pyramid. Deep within its heart, narrow, claustrophobic shafts angle upward from the king's and queen's chambers. For years, these were dismissed as ventilation shafts, but their design tells a different story. They are not horizontal, they are precisely angled tunnels pointing to specific patches of sky. In the pyramid's original configuration, around 2500 B.C., the southern shaft from the king's chamber pointed directly to the star Al-Nitak, the brightest star in Orion's belt. The northern shaft from the same chamber aimed at Thuban, the pole star of that era. Meanwhile, the southern shaft from the Queen's chamber targeted Sirius, the brightest star in the night sky, associated with the goddess Isis. These alignments were not for breathing, they were for the soul. Egyptian texts describe the deceased pharaoh's spirit, or Ka, traveling through these shafts to join these eternal, imperishable stars, becoming one with Osiris in Orion. The staggering fact is that this required precise knowledge of a slow celestial wobble called precession. The Earth's axis gradually shifts over a 26,000-year cycle, meaning the stars' positions in the sky change slowly over centuries. To build shafts that would align with specific stars at a specific point in that cycle required an understanding of this long-term astronomical motion. Did the pyramid builders observe the stars for generations to compile this data, or did they possess it from the start? This celestial mastery extended to time itself. The Egyptian calendar was a marvel of practicality and observation. They developed a solar calendar of 365 days, divided into 12 months of 30 days each, with 5 extra festival days added at the end. This was based on the annual rising of Sirius, the heliacal rising, which coincided with the Nile's life-giving flood. Their ability to predict this event to the day was crucial for their agricultural society and demonstrated a meticulous, long-term record of the stars. The question this precision forces upon us is one of origins. Such sophisticated astronomy feels fully formed at the dawn of the Old Kingdom. Tracking the precession of stars requires observations over centuries, far longer than a single civilization's recorded history at that point. Could this be the most compelling evidence for outside influence? Was this precise map of the heavens a legacy, a data set inherited from a much older culture that had watched the night sky turn for millennia? A culture for whom the positions of Orion and Sirius were not just religious symbols, but navigational markers or seasonal anchors carved into their own lost history. The stars above Egypt seem to tell two stories, one of a people deeply in tune with their universe, and another of a knowledge so deep it hints at a teacher lost to time. These celestial maps are a language, but to truly understand the message we must learn to read the speakers. The gods of ancient Egypt are often seen as fantastical myths, but what if we are reading them wrong? What if, woven into the elaborate symbolism of animal heads and cosmic battles, are clues pointing to the very real historical helpers we have been searching for? Let us re-examine these deities not as supernatural spirits, but as potential allegories for contact, as personifications of knowledge that seemed so advanced it could only have come from another world or another time. Take Osiris, one of the most central figures in their pantheon. He is not just a god of the afterlife. His myth is a story of a civilizing king. Osiris is credited with bringing humanity out of savagery. He taught the people of the Nile Valley agriculture how to cultivate the wild grain. He gave them the law, a code to live by. He introduced the arts of worship and the technology of winemaking. Then, in the story, he is murdered and dismembered by his brother Set, only to be reassembled and resurrected as Lord of the Underworld. Could this be a mythological retelling of actual history? A powerful, benevolent culture bearer, a teacher from afar who arrives with the gifts of civilization, is then killed or deposed, but whose teachings live on and become the foundation of a new society. The resurrection then symbolizes the enduring legacy of his knowledge, a system that did not die with its founder. In this light, Osiris is not a god of magic, but a metaphor for a transformative outside influence, remembered and deified over centuries. Then there is the Eye of Horus, one of the most famous Egyptian symbols. It represents healing, protection, and royal power, but look closer. The symbol was also used in a very practical way, as a system of measurement for fractions. The eye was divided into 6 parts, each with a specific value. The eyebrow was 1/64th, the pupil 1/32nd, the side curl 1/16th, and so on. These were not random. They formed a precise, standardized mathematical set used for measuring volumes of grain and land. This is a sophisticated, abstract system embedded in a sacred symbol. Could the Eye of Horus be more than a myth? Could it be the symbolic encapsulation of a system of mathematics and measurement that was given to them? The story says Horus lost his eye in a battle with Set, and it was restored by Thoth. This could be read as the loss and recovery of a precise body of knowledge, a system so vital it became synonymous with the state itself. This leads us directly to Thoth, the ibis-headed god of writing, magic, and wisdom. He is the scribe of the gods, the inventor of hieroglyphs, the patron of all sciences. He is the divine mediator and the keeper of sacred knowledge. If any single deity personifies the concept of an outside teacher, it is Thoth. He is not a king or a cosmic force like Ra. He is explicitly a bringer of information. In the Osiris myth, he heals the Eye of Horus with his wisdom. He is the archetype of the knowledgeable advisor, the one who provides the tools for civilization to function. Could Thoth represent the historical memory of a teacher or group of teachers who introduced the profound technologies of writing, advanced astronomy, and medicine? His animal form, the ibis, probes the mud for food with its long beak, a perfect symbol for seeking out hidden knowledge. Similarly, Ptah, the creator god of Memphis, is depicted as a mummified man holding a staff. He is the patron of craftsmen, architects, and sculptors. Unlike other gods who create by command, Ptah is said to have conceived the world in his heart and then brought it into being through his speech. He is the divine artisan. In a culture obsessed with monumental stonework, the god of craftsmanship would be of paramount importance. Ptah could be seen as the deification of the master builder's art itself, or perhaps the personification of the architectural and engineering principles that seemed so miraculously precise. If advanced construction techniques were introduced from outside, the memory of those master builders could have evolved over generations into the worship of Ptah. This perspective does not require literal spacemen. It suggests that when a less advanced culture encounters a vastly more advanced one, the result is not always a clear historical record. It becomes legend, then myth, then religion. The teachers are remembered not as human foreigners but as gods. Their tools become magical artifacts. Their knowledge becomes divine revelation. The intricate, sometimes bizarre symbolism of Egyptian gods might be the cultural echo of a real event, a moment of profound knowledge transfer so impactful that its source was forever shrouded in the sacred. The question then becomes, if the gods are the clue, what does the physical evidence of their earliest worship tell us? Where do we find the first temples, and what secrets do those foundational stones hold? The gods of Egypt may point to a teacher, but the echoes of their lessons appear in the most unexpected places. If we pull our gaze back from the banks of the Nile and look at the ancient world as a whole, a haunting pattern emerges. It is a pattern of similar shapes, similar stones, and similar stories, scattered across oceans and continents as if by design. This pattern forces a radical question: was ancient Egypt an isolated genius, or was it part of something much larger, a forgotten web of shared knowledge that once spanned the globe? Consider the most iconic shape, the pyramid. We rightfully marvel at Giza, but step across the Atlantic to the jungles of Mesoamerica. There, the Maya and the Aztecs built their own towering pyramids, like the Temple of Kukulkan at Chichen Itzá or the massive Pyramid of the Sun at Teotihuacan. The similarities are superficial but striking: a monumental stone structure with a flat top, often aligned to celestial events like solstices. The differences are profound. Egyptian pyramids were primarily tombs, sealed and smooth-sided, while Mesoamerican pyramids were functioning temples with steep staircases leading to summits for ritual sacrifice. The cultures had no known contact, so why the same basic, colossal form? One compelling answer is that the pyramid is simply the most stable way to build high with stone, a logical conclusion any advanced culture might reach independently. But when you add the shared obsession with astronomy into the mix, the coincidence begins to feel less random. Then look at the stonework itself, the fingerprints of the builders. Journey to the high Andes of Peru, to the fortress of Sacsayhuaman. Here, the Inca constructed walls from blocks so enormous they defy belief, some weighing over 100 tons. And they did not just stack them. They carved these irregular, polygonal stones to fit together like a three-dimensional jigsaw puzzle, with such precision that a razor blade cannot slip between them. No mortar was used. This is cyclopean masonry of the highest order, a technique that bears an uncanny resemblance to the foundational stones at the Osirion in Egypt or the mysterious walls at Ollantaytambo. Now travel to the Bekaa Valley in Lebanon, to the Roman temple complex of Baalbek. Beneath the Roman ruins lies a far older foundation, the Trilithon. This is a platform made of 3 limestone blocks, each estimated to weigh around 800 tons. A fourth, even larger block lies abandoned in a nearby quarry, weighing a staggering 1,200 tons. The scale is mind-numbing, dwarfing even the largest stones at Giza. How were these quarried, moved, and positioned? The cultures of Peru, Lebanon, and Egypt were separated by vast oceans and thousands of years. Yet they all chose to solve the problem of monumental construction with the same answer: move the mountain and fit it together with impossible care. Beyond stone, we find stories. Cultures worldwide share a foundational myth, the Great Flood. It is central to the epic of Gilgamesh from Mesopotamia. It is the story of Noah in the Hebrew Bible. The Greeks had Deucalion. The Maya spoke of a great deluge that ended a previous world age. And in Egypt, the god Set is said to have flooded the Nile Valley with red, bloody water. While details differ, the core narrative is universal: a catastrophic inundation sent by the gods to wipe the slate clean, with a warning given to a select few to preserve knowledge and life. Could this be a collective memory of a real, planet-altering event at the end of the last ice age, when rising sea levels swallowed coastlines and changed climates forever? A shared trauma imprinted on the mythology of every surviving culture. This constellation of similarities has led some researchers to propose a breathtaking idea: the existence of a global maritime civilization in deep antiquity. Imagine a seafaring people advanced in astronomy and navigation, who traversed the oceans during a warmer climatic period, perhaps before the great meltwater pulses made travel more difficult. This was not an empire in the traditional sense, but a network, a culture of explorers and teachers. They would have been the carriers of core ideas: the concept of megalithic construction for permanence, the knowledge of celestial cycles for calendar keeping and agriculture, and the spiritual frameworks that explained humanity's place in the cosmos. They would have made landfall in various regions, interacting with local populations. In some places, like the fertile Nile Valley, their knowledge took deep root and flourished, merging with local traditions to spark the sudden blaze of dynastic Egypt. In others, like the Andes or Central America, the seeds they planted might have lain dormant for millennia before blossoming into the Inca or Maya civilizations much later. In this model, Egypt is not the source, but one of the most brilliant and well-preserved inheritors. The Great Pyramid is not an anomaly, but a flagship artifact of a lost, interconnected age. This idea of a primordial source culture, sometimes called Atlantis or simply the mother culture, elegantly explains the global echoes. It provides the missing teacher, the seafaring disseminator of a common architectural and spiritual language. It turns the isolated wonders of the world into chapters of a single, scattered book, a book whose table of contents we are only now beginning to decipher. But a global maritime civilization is a vast, shadowy concept. To find a more tangible candidate, we can look to a specific time and place in history, to a people who actually existed and whose ships did sail the Mediterranean. This brings us to a more historically grounded possibility: the sophisticated Minoan civilization of Crete. Flourishing during the Bronze Age, centuries before the rise of classical Greece, the Minoans were not a myth. Their ruins tell a story of startling advancement. At the Palace of Knossos, we find evidence of a culture obsessed with elegance and engineering. They constructed multi-story complexes with intricate layouts, vivid frescoes depicting bull leaping and processions, and most tellingly, an elaborate system of terracotta pipes for fresh water and drainage. This was advanced plumbing in the 2nd millennium B.C. They were a maritime power, their graceful ships depicted on wall paintings, dominating trade routes across the Aegean Sea. Their influence stretched with artifacts found from Egypt to Anatolia. Then, around the year 1600 B.C., disaster struck. The volcanic island of Thera, modern Santorini, erupted in one of the largest cataclysms in human history. The explosion was apocalyptic, sending tsunamis racing across the Mediterranean and blanketing the region in ash. the Minoan civilization, centered just 70 miles to the south, was crippled. Its fleet was destroyed, its coastal settlements wiped out. Could survivors from this shattered, advanced culture have fled for their lives, and where would they go? The most stable, wealthy, and powerful neighbor to the south was Egypt, then in its New Kingdom period under pharaohs like Ahmose I. It is entirely plausible that refugee ships carrying not just people but the accumulated knowledge of a brilliant maritime society made landfall in the Nile Delta. These would not have been primitive refugees but the engineers, artists, and scribes of a high culture. They could have brought with them new artistic styles, advanced metallurgical techniques, or improved shipbuilding designs. We see a shift in Egyptian art and culture during this period, with more naturalistic frescoes and a focus on marine themes that some scholars suggest could reflect Minoan influence. This would not be a case of aliens or Atlanteans, but a realistic historical transfer of technology and ideas following a natural disaster. A parallel mystery from a slightly later period introduces another set of potential knowledge bearers, the enigmatic Sea Peoples. As the Bronze Age world collapsed around 1200 B.C., Egyptian records speak with alarm of confederations of invaders from the sea, attacking by ship and by land. The Medinet Habu temple reliefs of Ramesses III show fierce battles against these warriors, who wore distinctive feathered headdresses and fought from novel, streamlined ships. The origins of the Sea Peoples are one of history's great puzzles, with proposed homelands ranging from the Aegean to Anatolia to southern Europe. They are often cast as the destroyers of civilizations, toppling the Hittite Empire and sacking coastal cities. But what if, amidst the chaos of collapse, they were also carriers? Migration is not a one-way street of destruction. These moving populations would have been a melting pot of skills, languages, and technologies gathered from across the crumbling Bronze Age world. As some groups settled, whether through conquest or by being hired as mercenaries by the Egyptians themselves, they would have introduced new weapon designs, perhaps new weaving or pottery techniques, and certainly new perspectives. The key here is that influence is not always a peaceful gift from a superior teacher. Sometimes it arrives in the tumultuous wake of a storm, carried by desperate, skilled people fleeing a broken world. The Minoan refugee and the Sea People's warrior represent a different kind of helper, one rooted in the gritty reality of ancient geopolitics and natural disaster. They offer a bridge between the mythical lost civilization and the documented human genius of Egypt, suggesting that the spark of advancement could have been reignited not by gods from the stars, but by neighbors from across the water, bearing the salvaged knowledge of their own drowned world. The stone whispers one language, but the ink tells another. Among the most profound leaps in human history is the invention of writing, and here Egypt presents another startling anomaly. Around 3200 B.C., at the dawn of the dynastic era, hieroglyphs appear in the archaeological record not as clumsy, experimental pictures, but as a complete and sophisticated system. We find royal labels, administrative notations, and ceremonial inscriptions employing hundreds of distinct signs that already combine logograms, which represent whole words, with phonetic signs, which represent sounds. This was not a primitive scratchpad. It was a flexible, powerful tool for statecraft and religion, seemingly born fully formed. Contrast this with the long, documented evolution of writing in Mesopotamia. There, the precursor to cuneiform began centuries earlier as simple clay tokens used for accounting, evolved into pictographs pressed into clay tablets, and only very slowly, over hundreds of years, simplified and abstracted into the wedge-shaped script we recognize. That is the pattern we expect, a gradual development from practical record-keeping to complex literature. Egypt's script appears to skip the toddler stage and arrive as a literate adult. So where did this mature system come from? Could the very idea, the blueprint for writing, have been a cultural import? Some linguists point to a provocative and controversial clue. a possible deep-time connection between the ancient Egyptian language and the family of early Semitic languages, which includes Akkadian of Mesopotamia and the ancestral forms of Hebrew and Arabic. The structures share certain grammatical features and a core vocabulary that seems too fundamental to be coincidence. Words for basic kinship, body parts, and numbers sometimes show startling parallels. This has led to the theory that both language families might have branched off from a much older common ancestor, a proto-language spoken by a population in the distant past, perhaps in the Neolithic Sahara or the Near East. If that is true, then the people who carried this ancestral language might also have carried a toolkit of intellectual concepts, including perhaps the seed of a writing system. The sudden appearance of hieroglyphs, then, might not be an independent invention in total isolation, but the brilliant local flowering of a shared idea that had been gestating for millennia within a connected cultural sphere. It would mean the scribes of the first pharaohs were not inventing from zero, but refining and monumentalizing a system of notation they had inherited. The ink on those earliest palettes would be the physical evidence of a knowledge transfer so complete, it became the very voice of the civilization itself. While the ink of hieroglyphs tells a story of sudden intellectual maturity, the physical materials of Egypt hold secrets of a different kind. Beneath the artistry lies a chemical mystery, a mastery of substances that sometimes feels as advanced as their stonework. This is not about grand monuments, but about small, potent objects and lost formulas that hint at a science we are only beginning to appreciate. One of the most tantalizing artifacts comes not from Egypt itself, but from its ancient neighbor, Mesopotamia. Discovered in the 1930s near Baghdad, a set of curious clay jars dated to the Parthian period around 2,000 years ago has sparked endless debate. Each jar contained a copper cylinder and inside that an iron rod. The jars were sealed with asphalt, which would have held the rods in place and insulated them. If filled with an acidic liquid like vinegar or wine, this simple assembly becomes a basic electrochemical cell, capable of generating a small electric current. This is the so-called Baghdad battery. Mainstream archaeology is deeply skeptical of its use as a power source. Scholars suggest it was more likely used for electroplating, to deposit a thin layer of gold or silver onto objects, or perhaps it was a storage vessel for sacred scrolls. The truth is, no wires or associated electrical devices were found with it, but its existence proves a profound point. The ancient world was experimenting with chemical reactions and conductive materials. It demonstrates that the fundamental principle of a battery, a galvanic cell, was within the reach of ancient artisans. This immediately raises a pressing question. If such knowledge existed in Mesopotamia, could it have been known in Egypt, a civilization famed for its chemical expertise in mummification, cosmetics, and glassmaking? While no Egyptian battery has been found, the circumstantial evidence is provocative. They were master metallurgists creating alloys and gilding objects with exquisite skill. The famous gilded mask of Tutankhamun shows a perfection that suggests more than simple hammering. Could a form of electroplating, using a weak current from a cell like the Baghdad battery, explain some of their flawless metallic finishes? It is a speculative leap, but it highlights how a single, misunderstood artifact can open a door to reimagining an entire technological landscape. Even more concrete than speculative electricity is the Egyptians' undeniable command of chemistry, particularly in their adhesives. Walk through any museum displaying Egyptian statuary and look into the eyes of the gods and pharaohs. The inlaid eyes of stone or crystal in statues, like the magnificent seated figure of Pharaoh Khafre, are not merely socketed. They are held in place with an adhesive so powerful it has survived for over 4,500 years. This is not simple plant resin. Modern analysis has struggled to fully replicate its composition and strength. It was a complex cooked formula, likely involving plant gums, animal glues, and other organic compounds, creating a bond that was both incredibly strong and flexible enough to withstand temperature shifts without cracking or releasing its hold. This was a high-performance industrial adhesive, a product of deliberate, sophisticated experimentation. The formula was a guarded secret of the temple workshops, passed down through generations of artisan priests. And then, like so much specialized knowledge, it was lost. Its exact recipe vanished with the decline of the Old Kingdom's centralized workshops. Later civilizations, including the Romans, never matched it. This lost glue represents something profound, a package of applied chemical knowledge that was not theoretical but intensely practical. It was technology in a jar. When we combine the possibility of electrochemical experiments with the reality of such advanced material science, a pattern solidifies. It suggests the early Egyptians did not just stumble upon these formulas through trial and error over centuries. The sophistication seems too targeted, too effective from the very start of their monumental projects. Could these chemical secrets, like the principles of astronomy and megalithic construction, have been components of a larger, transferred knowledge package? A civilization focused on eternity would need more than just architectural plans. It would require the advanced chemistry to create the paints that never fade, the adhesives that never fail, and perhaps even the processes to refine and work metals in ways that still mystify us. These silent, potent substances may be the forgotten fingerprints of the teacher, embedded not in stone, but in the very molecules that held their world together. Yet for every echo of a lost teacher, there is a powerful and grounded counterargument, one built not on speculation but on the slow, steady accumulation of dirt and data. Mainstream Egyptology does not dismiss the wonders of the pyramids. It seeks to understand them through the tangible evidence left behind. The core of this argument is evolution, not revolution. Look at the sacred landscape of Saqqara, the vast necropolis just south of Giza. Here, written in stone, is the entire story of Egyptian tomb design, a clear, step-by-step progression. It begins with the mastaba, a simple, flat-roofed rectangular structure of mud brick or stone, the eternal house for the early elite. Then, around 2670 BC, the visionary architect Imhotep designed something unprecedented for Pharaoh Djoser. He stacked 6 mastabas of decreasing size on top of one another, creating the step pyramid. This was not a sudden leap from nothing. It was an architectural experiment, a bold enlargement of an existing idea. You can see the trial and error in its construction, the changes in plan as it grew. From this stepped form, the ambition grew smoother. At Medum, and later at the bent pyramid of Dosha, we see the transition, the attempts to create those perfect, smooth sides. The bent pyramid literally shows the correction in mid-construction, its lower half built at a steep angle before the architects realized the instability and finished it with a gentler slope. This is not the work of builders following a perfect, pre-existing blueprint from a lost civilization. This is the work of brilliant, practical engineers learning through doing, solving problems of weight distribution and structural integrity in real time. The Great Pyramid at Giza is not a mysterious first attempt. It is the magnificent culmination of over a century of relentless innovation. The evidence of how they did it is written in the very sand they stood on. Excavations around Giza have revealed the ruins of the workers' village, a carefully planned town with barracks, bakeries large enough to feed thousands, and infirmaries where skeletons show healed fractures, evidence of a medical care system. These were not slaves driven by the whip, but a skilled, rotating workforce, likely farmers who worked on the royal projects when the Nile's flood made their fields untouchable. They were paid in bread, beer, and a sense of participating in a divine project. We have found the quarries with blocks half-cut showing the tool marks. We have found the remnants of the ramps, the earthen causeways used to haul the stones ever higher. The most compelling evidence might be the so-called Diary of Mura, a collection of papyrus logs discovered at a Red Sea port. Written by a mid-level official, they detail the mundane, bureaucratic work of transporting limestone blocks from Tura to Giza by boat during the reign of Khufu. It is a timesheet, a delivery log, not a mystical manual. It shows the pyramid not as a magical event, but as the largest construction project of the ancient world, managed with the meticulous paperwork of a supremely organized state. From an Egyptological perspective, the mysteries often stem from a modern bias, an underestimation of what human ingenuity, when fueled by absolute religious conviction and centralized power, can achieve given enough time and labor. A copper saw might seem soft to us, but with the right abrasive sand and endless patience, it can cut granite. A ramp might seem inefficient, but with an endless supply of manpower and decades to build, it becomes entirely feasible. The celestial alignments are not proof of processional knowledge handed down, but the result of a culture that observed the stars with naked eye precision for generations, recording their movements on temple walls long before a single pyramid stone was cut. The opposition's case is powerful because it is complete. It does not require a vanished civilization or interstellar visitors to fill a gap. Instead, it presents a continuous thread from the first mastaba to the peak of Giza, woven from human ambition, brilliant problem-solving, and the immense, patient resources of a society united by a god-king. It asks us to replace awe for the unknown with a deeper awe for the known, for the sheer will of thousands of ordinary people who, block by block, built a mountain for eternity. So where does this leave us, standing between two compelling but opposing worlds of explanation? The awe we feel before the pyramids is a primal force, an almost physical pressure in the chest. This feeling is the true starting point of the mystery, and it creates a powerful psychological need. The official explanation of ramps and copper tools, for all its evidence, can feel like a slow deflation of that awe. It translates a miracle into a spreadsheet, a mountain of stone into millions of man-hours of grinding labor. Our modern minds, accustomed to rapid technological leaps, struggle to map that patient, collective effort onto the staggering result. The human psyche often resists the complex for the simple, the gradual for the sudden. This is where the idea of outside help performs its most seductive magic. It does not diminish the wonder, it elevates it. It takes the diffuse, overwhelming achievement of an entire civilization and concentrates it into a single, brilliant source, a lost teacher, a vanished library, a star-faring guide. This narrative gives our awe a name and a face. Instead of the anonymous toil of thousands, we imagine a conference of gods or a council of Atlantean elders passing down a sacred geometry. It transforms history from a slow, muddy climb into a moment of divine spark, a gift from a higher order. This taps into something ancient in our own storytelling bones, a love for the epic and the mythical. We are drawn to tales of fallen kingdoms, of elder races who walked the earth before us, of wisdom so profound it could only come from beyond. This framework makes the past not just a record, but a grand fantasy, a hidden chapter in a much larger and more mysterious saga. It allows us to keep the pyramids as magical objects, protecting them from being fully explained away. Believing they were built with tools we cannot find or knowledge we have lost preserves their power to astonish us. It means the greatest wonders of our world might still hold secrets, that history is not a closed book but a puzzle with missing pieces. This longing is not a sign of ignorance but a testament to the monuments themselves. They were built in part to inspire exactly this kind of eternal questioning, to bridge the gap between the human and the divine. The theory of outside help, then, is less about archaeology and more about legacy. It is our way of ensuring that the giants of the past never fully become just figures in a textbook, but remain as they were intended, eternal and enigmatic, forever just beyond our complete understanding. This desire for a magical source carries a dangerous, often unspoken cost. When we reach for star gods or sunken continents to explain the pyramids, we risk committing a profound historical theft. We risk erasing the ancient Egyptians themselves. Think about the underlying message of these theories. They whisper that the people of the Nile Valley on their own were simply not capable of such grandeur. That their civilization needed a boost, a push from a more advanced, often implicitly whiter or more European-like culture. This narrative did not emerge in a vacuum. Its roots are tangled with the colonial era, when European explorers first stood before the ruins of Egypt and other ancient wonders. Confronted with monuments that rivaled or surpassed their own, they faced a cognitive dissonance. The prevailing racist ideologies of the time could not reconcile the idea that the ancestors of the modern people living there, or people of African descent, could have been the architects of such splendor. So they crafted alternative histories. They credited lost tribes of Israel or wandering Aryans or survivors from Plato's Atlantis. They disconnected the achievement from the land and its people. This legacy subtly persists. The ancient astronaut theory, while often presented as a fun sci-fi speculation, can unintentionally echo this same dismissive chord. By suggesting the real architects were visitors from another world, it reduces the Egyptians to mere laborers or passive recipients, following instructions they did not understand. It strips them of their intellect, their creativity, and their agency. It turns a symphony of cultural achievement into a paint-by-numbers kit handed down from the stars. The truth is far more empowering. The story of self-made genius is not a boring one. It is the most inspiring story of all. It is the story of a society that observed the flooding of their river and created a calendar to predict it. That looked at the night sky and mapped it onto their landscape. That took simple copper and stone and through generations of trial, error, and brilliant insight learned to shape mountains. This is not a story of magic, but of monumental human effort, organization, and belief. To give the credit away is to disrespect that effort. It is to say their patience, their collective will, their ingenuity spanning centuries was not enough. That feels like a modern arrogance, an inability to comprehend a different scale of time and purpose. When we preserve the mystery by crediting outsiders, we are not honoring the Egyptians, we are comforting ourselves. We are making their world smaller, more familiar, more like our own myth of technological quick fixes, but their world was vast, deep, and profoundly their own. Their genius was not in possessing a secret manual we have lost, but in building a civilization so cohesive and driven that it could marshal the will of an entire nation toward a single, eternal goal for generations. That, in the end, is the greater wonder. Perhaps the most visceral mystery is the stone itself. How did they move blocks weighing 70 tons? The image of thousands of slaves straining against ropes feels both epic and insufficient. But archaeology offers a more elegant and in many ways more impressive picture. Recent experiments and wall paintings point to a brilliantly simple method. Workers would have prepared a smooth causeway from the quarry to the construction site. The massive stone block was placed on a sturdy wooden sled, then the key ingredient, water. By pouring water onto the sand in front of the sled, they dramatically reduced friction. The wet sand formed a firm, slick surface, preventing the sled from digging in and making it possible for a large but manageable team to pull the enormous weight. A painting from the tomb of Jehutuhotep shows exactly this, a colossal statue being transported on a sled, with a figure at the front pouring liquid onto the path. This was not brute force but applied physics. It turns the desert itself into a tool. For the truly gigantic stones, like the granite beams in the king's chamber, the journey began on the Nile. These blocks were floated on barges during the annual flood, when water levels were highest, bringing them as close as possible to the plateau. From there, a combination of sleds, rollers, levers, and ramps took over. The ramps were not a single, towering straight line, but likely a spiraling system built against the pyramid's sides, growing with it, or a more efficient zigzag design up one face. The organization required was monumental, but it was an organization of logistics, not magic. It was about coordinating the rhythms of the river flood with the construction season, about feeding the workforce, about maintaining the ropes and sleds. This was human achievement on a staggering scale, but every component of it is something we understand, something within the reach of a supremely motivated and well-run society. And what of the Sphinx, its weathered flanks seeming to whisper of a forgotten, rainy age? Geologists who support the traditional timeline offer compelling counter-arguments to the water erosion theory. They point out that the limestone of the Giza Plateau is not uniform. It has layers of varying hardness. When softer stone is exposed to wind-blown sand over millennia, it erodes in deep, vertical channels that can look very much like water wear. The desert wind is not a gentle brush, it is a sandblaster carrying abrasive particles that carve and undercut softer rock, especially at the base of a formation where sand accumulates. Furthermore, Egypt was not completely arid throughout its entire pharaonic history. There were periods of heavier, though not tropical, rainfall. The so-called Neolithic subpluvial, a wet period in North Africa, did not end as abruptly as once thought. Some climate models suggest pockets of significant rain could have occurred as late as the early dynastic period, right when the Sphinx is traditionally dated. This means the erosion patterns could have been formed by rainfall during the Old Kingdom itself, or even later, without requiring a date back to 7000 B. See, the weathering in this view is not an anomaly pointing to a lost civilization, but a testament to the statue's true, if still immense, antiquity within the known framework of Egyptian history. It is a reminder that nature works in complex ways, and that our first, most dramatic interpretation is not always the correct one. When we strip away the need for a mysterious teacher, what emerges is not a diminished story, but a clarified one. It is the story of a culture that looked at the sun's shadow and invented the world's first precision surveying tool, that harnessed the annual flood of their river as both a calendar and a highway. That learned through generations of trial and error how to shape, move, and lift mountains of stone. The mysteries begin to resolve into a mosaic of human skills, each piece remarkable but plausible. The precision was born from patience and acute observation, not a lost blueprint. The scale was achieved through social organization and communal belief, not alien instruction. This explanation does not rob the pyramids of their wonder. It grounds that wonder in something profoundly human. It asks us to replace awe for the unknown with awe for the known, for the collective will of thousands of ordinary people who, for the glory of their God-King and their own place in eternity, achieved the extraordinary. They did not need help from another culture because they were the culture that defined what was possible. Their legacy is not a question mark, but an exclamation point written across the desert sky. 3,000 years is a span of time we can barely grasp. It stretches from the fall of Troy to the launch of the first satellite, from the Bronze Age to the Internet. That is not a historical moment, it is the entire stage of human history, and that is precisely the timeline we must apply to ancient Egypt. Their civilization did not flash into brilliance and vanish. It endured, evolved, and built upon itself for over 30 centuries. This immense duration is the most crucial piece of context missing from the search for outside helpers. When we compress those millennia into a single snapshot of the Great Pyramid, the achievement seems like a miraculous, inexplicable leap. But when we stretch the timeline back out, the picture changes entirely. The leap dissolves into a long, steady walk. The so-called Pyramid Age itself was not a single project, but a sustained period of architectural ambition spanning more than a century. The Step Pyramid of Djoser was built around 2670 B.C. The Great Pyramid of Khufu rose roughly 100 years later. In between, at Meidum and Dosha, we see the experiments, the corrections, the learning in stone. That is 4 or 5 generations of master architects, each inheriting the knowledge, the skilled workforce, and the institutional confidence of the last. Imagine a family trade, a guild of builders where a grandfather might have worked on the step pyramid, his son on the bent pyramid, and his grandson on the smooth slopes of Giza. Knowledge was not lost between projects, it was compounded. Now, expand that view beyond the pyramids to the entire civilization. For over 3,000 years, there was a continuous cultural thread along the Nile. The language, the religion, the artistic conventions, the bureaucratic systems, they persisted. A scribe in the time of Ramesses the Great, 1,200 years after Khufu, could still read the inscriptions on those old kingdom monuments. The gods they worshipped were the same. This continuity provided a stable platform for incremental improvement across every field. Think of it not as one civilization, but as hundreds of successive generations living in the same cultural house, each generation adding a room, reinforcing a wall, or perfecting a decoration. A technique for cutting stone developed in the 4th dynasty could be refined over the next 500 years and applied to temple construction in the Middle Kingdom. An astronomical observation recorded in the early dynastic period could be verified and refined by priests for centuries, leading to the precise alignments we see later. This timescale makes the mysteries feel different. The question shifts from how could they possibly know this to what could they not learn given 3,000 years of focused, uninterrupted observation and practice. Given that span, is it really surprising they achieved such precision? With hundreds of generations to observe the stars, patterns like precession would eventually reveal themselves in temple records. With endless projects demanding stronger adhesives, is it a shock they developed a perfect glue? This perspective does not diminish their genius, it redefines it. Their greatest achievement was not a single pyramid, but the creation of a society so stable, so resilient, that it could sustain a collective project of civilization for longer than most modern nations have existed. The true wonder is not the stone, but the society that could organize itself around such a long-term vision. When we look for a single outside source to explain their knowledge, we are often revealing our own modern bias, our expectation of quick innovation. We live in a world of rapid technological jumps, where a new invention makes the last one obsolete in a decade. The ancient Egyptians operated on a different clock, a generational clock. Their progress was measured not in years but in lifetimes. What seems to us like a sudden spark of high civilization is, in this long view, simply the glow of a fire that had been carefully tended, fed, and built upon for 100 generations before it ever reached its brightest flame. Proof of an outside helper would not just add a footnote to history, it would tear out the entire introduction and rewrite the first chapter. The ground beneath our feet, the very timeline of human progress we have built our identity upon, would suddenly feel like a stage set concealing a deeper, older truth. If we could definitively prove that a guiding hand, whether terrestrial or otherwise, sparked the flame of Egypt and other ancient wonders, the implications would ripple through every layer of our understanding, from archaeology to philosophy. First and most fundamentally, the story of human civilization would cease to be a series of isolated, independent dawns. The lonely genius of Sumer, the Indus Valley, the Olmecs, and the Egyptians would be connected by a common thread, a single point of ignition. Human development would no longer look like multiple campfires spontaneously flickering to life across a dark plain. Instead, it would resemble a single, mighty torch carried from one kindling pile to the next, setting each ablaze in turn. This rewrites the narrative from one of parallel invention to one of cultural dissemination. The proud, independent origin stories of every ancient culture would become local adaptations of a global seed. Our maps would need new lines, not of empire but of knowledge migration, tracing routes across oceans we thought were uncrossable, through epochs we thought were silent. Technologically, the shock would be even more profound. it would mean that the pinnacle of human engineering was not achieved in the Silicon Age, but in a forgotten Stone Age. The Great Pyramid would shift from being a tomb to being a fossilized piece of high technology, its purpose perhaps entirely misunderstood. Our current trajectory of progress, that steady upward slope from stone tools to smartphones, would be revealed as a recovery, not an ascent. We would have to confront the possibility that humanity reached a technological and spiritual zenith thousands of years ago, only to lose it in a cataclysm or a slow forgetting, and have been climbing back ever since. This flips our arrogance on its head. We pride ourselves on our innovation, but we might just be archaeologists of our own lost greatness, slowly piecing together a science our ancestors mastered. The very materials we take for granted, concrete, steel, and silicon, might be crude substitutes for a lost art of manipulating stone and energy with a finesse we can barely measure, let alone replicate. But the deepest tremor would be philosophical, challenging our place in the cosmos. If the helpers were human from a lost Atlantis-like culture, the revelation would be a staggering lesson in humility. It would prove that civilizations are fragile, that even the most advanced societies can vanish, leaving only whispers in myth and indestructible stones as their epitaph. Our own modern civilization, for all its global reach, would suddenly feel ephemeral, a brief flash in a long, cyclical drama of rise and fall. We would have to ask ourselves, are we building anything that will speak to the ages, or are we just creating digital noise that will vanish when the power fails? If, however, the proof pointed to a non-human intelligence, the shift would be existential. It would mean we are not alone, and more shockingly, that we never were. The gods of every ancient pantheon would transform from mythic archetypes to potentially distorted memories of real contact. Religion, science, and history would collide and fuse in ways we cannot yet imagine. Our entire sense of human uniqueness, our belief that we alone in the vast cosmos crafted culture and consciousness, would evaporate. We would be the children, the students, perhaps even the creation of something older and wiser. So, is this a humbling or an empowering revelation? The answer is both, in a deeply paradoxical way. It is the ultimate humility to realize our story is not solely ours, that our greatest achievements might be echoes of a teacher's lesson. It shatters human exceptionalism, yet there is a strange empowerment in that same thought. It means the blueprint for greatness, for harmony with the cosmos, for building things that last millennia, is not a fantasy. It is a real possibility etched into our planet's very bedrock. It means the potential for that level of achievement is woven into the human story, because in some form we were there. We either built it with guidance or we built it ourselves and forgot. Either way, the proof would tell us that the Golden Age is not just behind us in a misty past, but also a potential future, a destination we can reach again if we can only remember the way. The silent stones would finally speak, and their message would change everything we thought we knew about who we are and what we are capable of becoming. The search for answers no longer relies solely on trowels and guesswork. A quiet revolution is unfolding in the deserts of Egypt, powered not by wild theories, but by silent, invisible particles and beams of light from space. This is the modern quest where cutting-edge technology acts as a key, probing the stones for secrets they have held for millennia. Take the Great Pyramid itself. For centuries, its interior was considered fully mapped. Then, scientists turned to a cosmic messenger, the muon. Muons are subatomic particles that rain down from the atmosphere, passing through solid matter much like an X-ray. By placing sensitive muon detectors inside the pyramid, the Scan Pyramids project could essentially take a density scan of the entire structure, revealing voids where fewer muons were absorbed. In 2017, they announced the discovery of a large, previously unknown void above the Grand Gallery, a hidden space the length of a passenger plane. This was not speculation, it was physics. The discovery did not immediately reveal a treasure chamber or an alien reactor. it revealed emptiness, a structural mystery that Egyptologists are now working to understand within the pyramid's known architecture. It proves that even our most iconic monuments still have rooms we have never entered, chapters of their story left unread. From the subatomic scale, we zoom out to a bird's-eye view where satellite archaeology is rewriting the map of ancient Egypt. Orbiting cameras equipped with infrared and high-resolution sensors can detect subtle differences in soil density and plant growth. A buried mud brick wall retains moisture differently than the surrounding sand, causing the grass above it to grow slightly taller or greener. From hundreds of miles in space, these patterns become clear, tracing the outlines of streets, houses, and temples long ago swallowed by the desert. This technology has led to staggering discoveries, like the identification of the lost city of Ichtoi, the capital of Egypt's Middle Kingdom, and countless unknown settlements along the Nile's former branches. Each new outline on the screen is a pixel in a recovering portrait of a living, breathing civilization far more extensive than the stone tombs alone suggest. Perhaps the most transformative tool is LiDAR, which stands for light detection and ranging. Mounted on a plane or drone, it fires millions of laser pulses at the ground. By measuring the time it takes for each pulse to bounce back, it creates an exquisitely detailed three-dimensional map of the surface, digitally stripping away vegetation to reveal the bare earth beneath. In the dense jungles of other continents, LiDAR has revealed entire lost cities. In Egypt, it is being used to map vast necropolises with pinpoint accuracy, revealing thousands of unexcavated tombs and the intricate network of ancient roads that connected them. This technology allows archaeologists to see the landscape as the ancients did, to understand the relationship between a pyramid, its workers' village, its quarry, and its ceremonial causeway as a single, integrated complex. It turns a collection of ruins back into a planned community. These tools share a common, powerful philosophy. They are methods of seeing without digging, of asking questions without disturbing the very history we seek to understand. They represent a shift from destructive excavation to precise, surgical investigation. When a muon scan hints at a void or a satellite image reveals a city wall, it provides a target. Archaeologists can then plan a minimal, careful excavation, knowing exactly where to look. This preserves context, the most precious and fragile commodity in archaeology, which is the relationship between objects. A single pot shard means little, but that same shard found in the kitchen of a baker's house in a satellite-revealed settlement tells a story of daily life. This is how the full, rich narrative of ancient Egypt is being reconstructed, not through a single dramatic find, but through the patient accumulation of millions of data points. The promise of this technological search is profound. It moves us beyond the binary debate of outside help versus solitary genius. Instead, it seeks to understand the how in breathtaking detail. It aims to map the entire supply chain of a pyramid from the quarry to the capstone. It wants to digitally rebuild the ancient climate and river courses to see how they influenced settlement. It hopes to analyze microscopic residue on tools to understand the exact compositions of their lost adhesives and paints. The answers may not be a crashed starship or a map to Atlantis. They are more likely to be logistics tables, seasonal work schedules, and refined engineering principles that emerged from generations of practice. The real mystery being solved is the incredible sophistication of their organization, a different kind of advanced technology that left no metallic artifacts, only a society that functioned like a perfect machine for centuries. The stones may finally give up their secrets not to treasure hunters, but to particle physicists and data analysts, revealing that the greatest wonder was the civilization itself, now coming back into focus one laser pulse, one muon, one pixel at a time. Perhaps the true answer lies not in a stark choice between two extremes, but somewhere in the fertile middle ground of human interaction. The most compelling resolution to this ancient mystery might not involve gods, starships, or blueprints from a sunken continent. Instead, it could be a story of a spark, a single catalytic encounter that ignited a latent potential already burning within the people of the Nile. Imagine a scenario far more subtle and historically plausible than an invasion of Atlanteans, a violent storm in the Mediterranean sometime in the late 4th millennium B. C. A ship from a more advanced culture, perhaps early Minoan explorers, or skilled metalworkers from the Levant is caught, driven off course, and wrecked on the marshy shores of the Nile Delta. The survivors are not a conquering army, but a handful of desperate, knowledgeable individuals. They are a ship's carpenter who understands advanced joinery, a navigator who can read the stars by methods slightly more refined than the locals, and a metalsmith who knows the secrets of alloying copper to make it harder. They are taken in by a local chieftain, not as gods but as fascinating curiosities. In exchange for shelter and safety, they share what they know. They demonstrate a better way to lash a raft together for moving heavy stones. They sketch in the sand a more efficient pulley system using ropes and logs. They show how to mix certain minerals with copper to produce a bronze-like edge that lasts longer. This is not a transfer of a complete civilization. It is the gift of a few key ideas, a handful of intellectual seeds. The Egyptians, already a complex and organized society with their own sophisticated understanding of their world, did not simply copy these seeds. They planted them in the rich soil of their own culture. They took that pulley concept and scaled it up, applying it to blocks of a size the shipwrecked sailor never dreamed of. They absorbed the metallurgical trick and then spent generations perfecting it, creating the exquisite ceremonial blades we find in royal tombs. The astronomical tip became the foundation for a priestly obsession, leading to centuries of meticulous observation that yielded the precise alignments of Giza. In this middle ground view, the outsiders were not the architects but the accidental mentors. They provided a crucial nudge, a shortcut on the path of technological development. They answered questions the Egyptians were already asking, but solved them with methods born from a different set of experiences. This model respects the evidence on all sides. It acknowledges the sudden, seemingly mature appearance of certain technologies and artistic styles that Egyptologists themselves note could indicate foreign contact in the predynastic period. Yet it completely preserves the agency and the overwhelming genius of the Egyptian civilization. They were the ones who saw the potential in these new ideas. They were the ones with the social organization, the religious drive, and the collective will to mobilize thousands and apply these concepts on a literally monumental scale. The shipwrecked sailor might have known how to make a better sled, but only the pharaonic state could command the creation of a 5-mile limestone causeway to use it on. This synthesis transforms the narrative from a mystery of construction into a story of inspired adaptation. The Great Pyramid is no longer a question mark pointing to a lost teacher, but an exclamation point celebrating a culture brilliant enough to recognize a good idea and then magnify it beyond the imagination of its originator. It allows for a whisper of external influence without ever shouting down the thunderous voice of Egyptian achievement. The civilization along the Nile remains the sole, undeniable author of its own epic, but perhaps in a forgotten prologue, it had a fascinating conversation with a stranger from across the sea, a conversation that helped it find its own voice more quickly and more powerfully than anyone could have predicted. So we find ourselves at the end of a long journey, standing between two worlds. One world is filled with tantalizing anomalies, the Sphinx weathered flanks, the Osirion's impossible stones, the stars perfectly mapped in stone. It is a world of captivating what-ifs, where the echoes of drowned continents and star-born teachers offer a grand, unifying answer to history's greatest puzzles. It is a narrative of epic mystery where our past feels larger, deeper, and infinitely more wondrous. The other world is built from the robust counterarguments of archaeology. The clear progression of tombs at Saqqara, the workers' village at Giza, the simple genius of wet sand and sleds. This is the human scale world where 3,000 years of patient collective effort, fueled by an unshakable belief, accomplished the extraordinary through sheer will and brilliant organization. This is the narrative of epic human effort. Both stories are compelling, both demand our respect. The first speaks to our sense of wonder, our desire for a past that still holds profound secrets. The second speaks to our awe of human potential, our capacity for greatness when we are united by a common purpose. Perhaps the most honest conclusion is that the true wonder of ancient Egypt lies precisely in this tension. It lies in what we know they did achieve, a mountain of evidence for their own genius, and in those stubborn, silent gaps that keep the conversation alive. Whether they built entirely alone, or whether they received a crucial nudge from a conversation now lost to history's deepest pages, the result is the same, a legacy carved in stone that continues to humble and inspire us millennia later. Their civilization stands as a testament to what is possible, a mirror reflecting both our deepest mysteries and our highest capabilities. So as the script ends, we leave the final question with you. Which narrative resonates more deeply in your mind, the epic mystery of a lost teacher or the epic triumph of unaided human effort? The stones of Giza are not going anywhere. The debate, like the Nile, will keep flowing. Share your thoughts in the comments below. Let's have a heated but respectful conversation. If you enjoyed this exploration into the shadows of history, be sure to like this video and subscribe for more journeys into the unknown.